Hello everyone. Today we are going to solve the famous two-sum problem. We are given an array of integers nums and an integer target. We have to return indices of two numbers such that they add up to target. We may assume that each input would have exactly one solution and we may not use the same element twice. We can return the answer in any order. Before we go ahead and code up our solution, let's take a moment and just go through how to solve this problem in the most optimal manner. So let's take an example. Let's say we have nums array as 2, 7, 11, and 15, and we have our target value of 17. So the output in this case would be index 0 and index 3, because the value at index 0 is 2 and the value at index 3 is 15. So 2 plus 15 is equals to 17. So the output will be 0, 3. The brute force approach to solve this problem will be to use two for loops, one starting from index 0 and the other then starting from the very next index, and then traversing each element twice, seeing whether there are two numbers which add up to target. If there are, just return their indexes. So the time complexity, since we're using two for loops, would be big O of n squared, wherein is the number of elements in nums, and the space complexity would be big O of n, since we are not using any auxiliary space. Can we do better? Yes. We can bring down the time complexity to big O of n while increasing the space complexity to big O of n as well. And that can be solved by using a hash map. Let's see how. So to solve this problem in the most optimal manner, we have to use a data structure called hash map or dictionary, whichever way you want to call it. So we have the indexes 0, 1, 2, and 3. We have this nums array. We have the target t equals 17. Let's just first understand what we're trying to put into the dictionary or the hash map. So within the hash map, there will be a key value pair. The key in this case will be the numbers within nums itself, and the value will be the index at which that particular number is present. So for example, if 2 is present at index 0 and we want to put 2 as the key value, as the key, the value will be basically 0. Now our target will be to find, is there a value t, target t minus nums of I present within the dictionary itself. If we call the dictionary as t, is this value t minus nums of I, is it present within the dictionary? If it is present, our job is done. We basically return the value corresponding to this key and the index I in itself. Let's see how it is working in this particular example. So we start at index 0. We check, is 17 minus nums of 0, which is 2, equals 15 present within the dictionary? We say no. So what we are going to do is we are going to simply put the number 2 and its corresponding index value 0 within the dictionary. Then we'll go on to the next value, which is 17. So we check, is 17 minus 7 equals 10 present within the dictionary? We say no. So what we are going to do is we are going to put 7 and its corresponding index value as 1 within the dictionary again. We'll move on to the next value, 11. We'll check, is 17 minus 11 equals 6 present within the dictionary? We say no. So what we are going to put is 11 and its corresponding index, which is 2 in this case, and then we'll move on to the next value, which is 15. Now here things becomes interesting. We see 17 minus 15 equals to already present within the dictionary, and that is what we had wanted. So what we are going to return is the value corresponding to this particular 2, which is target t minus nums of I. We are at index I equals 3, so we want to return the value at target t minus nums of I, which is equals to 3 in this case. So that target t minus nums I is equals to 2, and that value corresponding to 2 is 0. So we'll be outputting the value 0 and the index I, which is equals to 3 over here, as the solution, and this is our answer. Since we are traversing the entire nums array only once, our time complexity would be big O of n, and since we're using an hash map, so that is auxiliary space that we're using, so the worst case space complexity would be big O of n as well, and this is the optimal way to solve this problem. Let's take a look at the Python code to solve this problem now. So let's take a look at the solution to this problem in Python. So we have been given a function to sum. It takes nums, which is a list of integers, and then a target, which is an integer value. We are asked to return a list of integer which represents the indices of the two numbers such that they add up to target. So first things first, let's just import default tick from the collections library, because that's how we define the dictionary in Python. So from collections, import default dictionary, and we will define our dictionary over here. So what I had mentioned before, we'll be starting from index 0. We'll be traversing all the way to the end of the nums array. So we can write a simple for loop. So for I in range len of nums, what we are going to check is the value target minus nums of I present within the dictionary. So a simple way of doing that will be like writing a simple if else statement. So if target minus nums of I, so is this value in the dictionary that we had defined. So if it is present, our job is done. We simply need to return the value corresponding to this particular key. So the way to do that will be like this: dictionary of target minus nums of I. So this will give us the value, which is the index of the second target of the second number that we wanted to find, and the first index of the first number will be I itself. And since we can return this in any order as mentioned in the instructions, so this will work. If we don't find this particular number in dictionary, what we are going to do is we will simply store the nums of I value as the key and its index as the value to this particular key. So that will be I. And again, this problem says that we will have exactly one solution. It doesn't mention that there might be scenarios where we won't find a solution, but so basically your program is going to like terminate at some point on this particular line. It's not going to come on line number 10. But just to ensure that we write a good code, we just want to ensure that we handle this particular case where we pass through this entire nums array and we don't find a solution. So in that case, just walk through your interviewer what he or she wants. If they want an empty list, it's fine. If not, some of interviewers prefer -1 but for the sake of this video, I'm just using like an empty list. So yeah, that should work. Let's just see if our solution runs properly. So as you can see, it has passed all the 3 test cases, and now it's time for us to submit the solution. Yeah, there you go. So it beats almost 92% of users in Python in terms of runtime, and memory it beats like 50%. So it's a pretty good implementation. So yeah, that's all about this two-sum problem. Do make sure to like this video and subscribe to this channel. I will meet you in the next video. Thank you.